So today what we were looking at was on some of the basic concepts or principles of thermodynamics. And under thermodynamics, we'll basically look at the three laws of thermodynamics: the first law, second law, and the third law. So some of the concepts that we will basically, for those of you who are able to follow today, we are looking at, we say that for the purposes of thermodynamics, the universe is made up of two parts basically. So we have, if I was able to draw that like that, and another one there. So we can have our system there, and then we have our surrounding there. So the universe is basically made up of the system and the surrounding. Between the between the system and the surrounding is the boundary that we have here. So the system is the part of the world in which we have a special interest. You know, like maybe we are looking at some reaction in a given vessel, or maybe you want to look at the engine, like we'll look at it much later. Or you look at the behavior or the actions of an electrochemical cell or even a biological cell. So that becomes your system. Then you look at its relationship with its surrounding. So the surrounding it comprises the region outside the system and where we make measurements. So this is where we take our measurements. You can measure change in heat, you can measure change in temperature, and a number of things. So the type of system depends on the characteristics of the boundary that divides it from the surroundings. Okay, so the system, the type of system, we'll see the three types of systems. It is basically determined by the kind of boundary that separates it and the surrounding. So we have three types of systems. We have the open system, we have the closed system, and then we have the isolated system. So these three, if we look at movement, we look at movement of matter and energy across the boundary. So we are saying that if matter can be transferred through the boundary between the system and the surrounding, then we call that system an open system. So that is what we have there as open system. And if the matter cannot pass between the boundary that surrounds the system, there is no exchange of matter between the system here and the surrounding, then we call that a closed system. Why? Because matter or mass cannot be transferred from the system to the surrounding and vice versa. But energy, which is mostly in terms of heat, can be transferred. So energy can be transferred from the system to the surrounding. So I hope you're able to see that. A closed system can expand and thereby raise weight in its surroundings. A closed system may also transfer energy to the surroundings if they are at a lower temperature. So there can be some movement of heat from hot to cold, and that can be measured in terms of change in energy. So that is transfer of energy. An isolated system, we see that there is neither transfer of matter nor transfer of energy between the system and the surroundings. Okay, so they have neither mechanical nor thermal contact with its surroundings, and it's because of the kind of boundary that we have. Some other definitions that we are also looking at is work is a major part of is a major property that we are going to look at in thermodynamics, because the work done is the main thing that we'll be focusing on, the work done by the various systems. And then in terms of thermodynamics, there's something that we say that either work is done by the system or the work is done on the system. So we will also be able to look at that. One is negative, one is positive. But if we look at here, work is done to achieve motion against an opposing force. So when you're able to achieve a motion against an opposing force, then we call that work. And there are a number of examples that we're going to look at. A simple example is a process of raising a weight against a pull of gravity. So as you carry that weight and you raise it up, then work is done. Then we also have a case where you have in a cylinder and a piston there, and you have gas here, and this gas pushes the piston. So we are saying the expansion of a gas that pushes out a piston, the motion of the piston can in principle be used to raise weight. So as it pushes this piston up, then this can be able to raise weight. Then also a chemical reaction that drives an electric current through a resistance also does work. There's an opposing force, there's a motion you're achieving against the opposing force, and that is why we say that work is done. Okay, so these are some descriptions of work in relation to thermodynamics. And now when we look at energy, the energy of a system is its capacity to do work. Okay, the capacity of a system to do work. So when work is done on an otherwise isolated system, remember what we said, isolated system, matter, energy cannot pass. So for instance of compressing a gas or winding a spring. So if we compress a gas, assume it's like that, and you compress it, then you give it a higher chance of doing a much better work. Okay? Because you are building the pressure here. So when you leave it, and it can easily push something up. So when you compress a gas, the capacity of the system to do work is increased. In other words, the energy of the system is increased. When you have a spring, like even if you look at the shocks of a vehicle or even of a bike, when you press it down, then you give it a higher capacity to do work. That means the energy of the system is increased. Okay, so that is what energy, how energy and work is related. But when you expand this, then it will do less work. So the energy of the system is reduced and it can do less work than before. When the energy of a system changes as a result of temperature difference between the system and its surroundings, we say that energy has been transferred as heat. Okay, so when we look at temperature changes that occurs between a system and the surrounding, then we look at that energy in form of heat. When you take a heater and you immerse it in a beaker of water, the water becomes our system. The capacity of that system to do work has increased because the water has become hot, and hot water can be used to do more work than cold water. And so we see how work, system, and energy is related. And it is very important for us to be able to follow these definitions. So in terms of boundaries, we are saying that not all boundaries permit the transfer of energy, even though there is a temperature difference between the system and the surrounding. So when we talk of boundary there, or when I draw a system, a surrounding, and then we have our boundary there. Then we are saying that not all these boundaries will permit transfer of energy, even though there's a temperature difference. Okay, so not all of them will allow. So boundaries that do permit, the ones that allow the transfer of energy as heat, they are called diathermic. So they allow transfer of energy in form of heat. Okay, an exothermic process, which I believe we know, the process that releases energy to its surroundings. Okay, so when a reaction occurs and maybe there's a lot of heat here and it is released to the surrounding, that becomes an exothermic process. But for it to release that energy, then this boundary mass is very significant. Which kind of boundary? If it is diathermic, it will allow. But there are those that do not allow, and that is what we are calling adiabatic. So adiabatic will not allow, even though there could be temperature difference between the two. So we have exothermic processes, and then we have endothermic process in which energy is required, is acquired from its surroundings. So the system here will take energy from the surrounding for endothermic. And one of the best examples is a vaporization of water. It absorbs heat. Okay, it absorbs heat, and so it is an endothermic reaction. And finally, when we look at exothermic processes, energy is transferred as heat to the surrounding, while in endothermic process, we are saying energy is transferred as heat from the surrounding. So when you have the surrounding, we have the system and the surrounding. So either heat is transferred from system to surrounding or from surrounding to the system there. Okay, so that is endothermic. An endothermic process in a diathermic container results in energy flowing into the system as heat to restore the temperature to that of the surroundings. So we are saying that we have endothermic process, absorbs heat, diathermic allows movement, and so we are saying that there will be a movement there, and the heat here will flow from where it is high to where it is low. So it will absorb more heat. So we are saying that it results in energy flowing into the system as heat to restore the temperature to that of the surroundings. An exothermic process in a similar diathermic container results in release of energy as heat into the surrounding. So heat is high here, produces heat. It's lower here, so it will move like that. And the reason why it's able to move is because this is diathermic. The boundary there is diathermic. When an endothermic process takes place in an adiabatic container, it results in lowering of temperature of the system. Because it uses energy, so the temperature here will be lower, because this does not allow movement of energy from outside. But for exothermic process, because it produces heat, the temperature will rise. And so that is what we are having represented here in these diagrams. Okay, so this is basically what we have to describe the endothermic process, exothermic process in both in a diabatic container and diathermic container. I hope you're able to follow it.